Assalamualaikum and hi everyone, this is Dr. Shazira. In this video, we are going to be solving the heat equation using Crank Nicolson scheme. In the Crank Nicolson scheme, the uxt is approximated to uxitj plus half. Okay, so if you can recall the explicit scheme before this, the uxt is approximated to uxitj. Okay, but for the Crank Nicolson scheme, t is at j plus half. Okay, that is the difference between Crank Nicolson and implicit scheme. Okay, so this term here, in short, we can write as ui j plus half. Okay, so it means now in terms of the grid, okay, so this is what you have earlier. Okay, you have uij, and to your right is uij plus ui plus 1j, and so on and so forth. Okay, at the top here you have uij plus 1. Okay, because here the level of the level of y-axis is j plus 1, and this is at j. All right, so by the Crank Nicolson scheme, so it means you have a point in between. Okay, so if we locate uxitj plus half or uij plus half, it should be here. Okay, this is where you have your uij plus half. Okay, it should be there. All right, so before this, the step size of t, okay, delta t, you denote as k. So it means the difference between uij plus 1 and uij, so the length between this point and this point is k. Now, since you have a point in the middle, so the step size or the length, the distance over there to the middle point is k over 2, and this is another k over 2. Okay, so basically you still have k, which is the distance between uij plus 1 and uij. All right, so that is our diagram, that we will consider for the Crank Nicolson scheme. Okay, so now back to our heat equation. So the heat equation is given by del u del t is equal to c square, okay, del square u del x square, or in short, sometimes you have in this form u sub t is equal to c square u x x. Okay, so now the same thing as before, by the finite difference method. So it means, you need to substitute the derivative term in your heat equation using the finite difference formula. So by the Crank Nicolson scheme, the u sub t, okay, we are going to use the centered difference formula. Okay, centered difference formula, and u as x also, we apply the centered difference formula as well for uxx. Okay, before this, in explicit scheme, for the u sub t, we use the forward difference, if you can still remember. But for the Crank Nicolson scheme, the u sub t here, we are going to be using the centered difference formula. Okay, but mind you, this u sub t here is now being considered at the point, j plus half. Okay, it's not j, it is j plus half. So the formula will be, of course, will be different from the explicit scheme. Okay, so now if we write our u sub t, okay, so this u sub t at the point x and t is approximated to, again, as I've mentioned just now, it is approximated to xi t j plus half. Okay, you can write as u t I j plus half here. Okay, so now what is the formula? Okay, so we are going to be using the centered difference formula. So see, you want to find u sub t at this point. Okay, so u sub t is the derivative with respect to the time. So it is temporal derivative. So you will be considering the vertical line here. Okay, so by the centered difference formula, so if you are here, you are at uij plus half. So by the centered difference formula, it is the forward node minus the backward node over 2 times the step size. Okay, so what you are going to have, okay, the centered difference formula will be u, at the top you have uij plus 1 minus the backward um, node is uij. So now you have over 2 times the step size. Okay, because you are at uij plus half, so the step size is k over 2. It is not k. Okay, so by that formula, so you see you can simplify 2 at the bottom. So you will end up with uij plus 1 minus uij over k. Okay, so this is actually centered difference formula at the point xitj plus half. Okay, so seems like if you see this formula, it is somehow the forward difference. Okay, so before this we say that this is the forward difference formula, but this is the forward difference formula at, approximated at xitj. Okay, but now this is approximated at xitj plus half. Okay, so it is not a forward difference. Actually, this is centered difference. You evaluate at xitj plus half. Okay, so that is our u sub t. Okay, so by the Crank Nicolson scheme, so it means that the u sub t here need to be replaced by this expression here. So that is the first one. Okay, now look at this guy here, uxx. Okay, the centered difference formula. So by right, the uxx. Okay, so before this, if you can recall the uxx, okay, if you evaluate at I and j, so uxx is given by ui plus 1j, okay, minus 2uij plus ui minus 1j over h square. Okay, so if you can recall, so I put somewhere here. Okay, before this you have for the centered difference, for the uxx, okay, you evaluate at I and j. So this is given by ui minus 1j, okay, minus 2uij plus ui plus 1j over h square. Okay, so that is what you have in the explicit scheme before this, because yeah, you are evaluating at this point, okay, uij. So it is the left node minus 2 the middle node plus the right node over h square. So h is basically this step size here. So by right, okay, if you want to have the uxx at the uij plus half, so by right you are considering this node somewhere here at your right, and also this node somewhere here at your left. Okay, so by right, the uxx, okay, is supposed to be no ui minus 1 j plus half, okay, minus 2 ui j plus half plus ui plus 1 j plus half over h square, because uxx here you approximate at I j plus half. Okay, so by right you are using this node here, ui minus 1 j plus half here, and you are using the right node here, ui plus 1 j plus half. Okay, to get the second derivative, evaluate at this point. Okay, so but somehow we don't have the nodal, we don't have the value at this nodal point at the left and at the right hand side here. Okay, so I'm going to write here, we don't have the value at the nodal point j plus half. Okay, so it means, okay, we don't have the value here, ui minus 1 j plus half. We don't know the value of ui plus 1 j plus half here. Okay, so we cannot, use this formula here. So therefore, uxx, okay, at the nodal point I j plus half will be obtained by taking the average, okay, by taking the average of uxx at the nodal point I j plus 1 and ij. Okay, so by the grid it is this point. Okay, so we want to have the second derivative evaluated at I j plus half. So here. Okay, but we cannot use this guy and this guy at the left and right hand side because we don't have the value at those points. Okay, so what we are going to do is by taking the average of uxx at this point, okay, and this point. Okay, so you take the uxx at this point, okay, plus with the uxx at this point, and then you divide by 2. That is average. All right, so in other words, we have this expression here. So 1 over 2 uxx at ij plus 1 plus uxx at the point I and j. Okay, so what do we have? So therefore uxx, okay, now it's approximately, so I put 1 over 2 and then you have a big bracket here. So you see this uxx ij plus 1. So how do you find, the second derivative at this point? By using the centered difference formula. So it is the left node minus 2 times the middle node plus the right node over h square. Okay, so we have, okay, so put bracket over there. So you have ui minus 1 j plus 1, okay, minus 2 ui j plus 1, okay, plus ui plus 1 j plus 1 over h square. So that is uxx, okay, evaluated at I j plus 1. So put here. And then plus with the uxx evaluated at I and j. I and j is at the bottom. So here, okay, so the centered difference formula, okay, for the second derivative at this point is the left node here, okay, ui minus 1j minus 2 times the middle node, so 2 times uij plus the right node ui plus 1j over h square. So you will have ui minus 1 j minus 2 uij plus ui plus 1 j over h square. All right, so you can see h square, okay, you share the same denominators, so which can be grouped together, or you can take out h square, okay, together with the 1 over 2, so that you have here 1 over um, h square, 1 over 2 h square. Okay, so that in the bracket you can see you have 6 terms of u somehow. Okay, so you can write down one more time the terms in the bracket. Okay, so in the bracket, so you will have this 6, okay, terms of u. Okay, so now what happened to our heat equation then? So it means that now in our heat equation, u sub t c square uxx here. So for the u sub t, you are going to be replacing with this finite difference formula here, this guy here, and for the uxx, you are going to be using this formula. Okay, so you put everything together, so it means you are going to have quite long expression, okay, for your heat equation in the form of finite difference method. All right, so this is your heat equation looks like in the finite difference form. So this is your u sub t equals to c square 2h square. Okay, so you take out the h square, okay, earlier. So this is the 6 terms in the bracket. Okay, and then if we consider the k here, you put at the right hand side, so you have k c square over 2h square, and if we let this fraction here to be r, so we have this kind of expression here. Okay, rearrange the equation, the expression that you can see here into this. So the idea is to put terms at the level j plus 1, okay, to be at the left side, okay, and terms with the j level, a level of j, so you put at the right hand side. Okay, so at the left hand side you have ui minus 1 j plus 1, okay, and ui j plus 1 as well as ui plus 1 j plus 1. Okay, so try to rearrange your expression according to the position in the grid. Okay, so this guy can be on the left, and this one in the middle, and this one at the right. Okay, so try to put in that way. The same thing at the right hand side. So everything on the right hand side involve nodes at the level j. Okay, so for the I, okay, so you put I minus 1 first, and in the middle is ui, okay, and at the right is your ui plus 1. So this is again your heat equation in a finite difference form. All right, so this expression here can be summarized in terms of molecule diagram. Okay, so what you can see at your left hand side here is basically all the molecule at the top here. So ui minus 1 j plus 1, okay, and negative r is the coefficient, and in the middle you have this guy here, ui j plus 1, okay, translated into this molecule, where 2 plus 2r is the coefficient, and the same thing for this guy. Okay, and this is again at the top here is the expression on the left side of your equation, and this one is equal to the addition, okay, of the three nodes, the value of three nodes at the bottom. Okay, so ui minus 1j, coefficient is r, and this point here is in the middle, and the right node, okay, for this guy r ui plus 1j, and the targeted cell, yeah, should be this guy, the same cell or the same molecule as the explicit scheme. Your targeted cell is ui j plus half. All right, sorry, j plus 1. All right, so those basically how you come out with the formula, okay, in terms of Crank Nicolson scheme. Okay, what is the difference between explicit scheme? So you should be able, to write down the heat equation, in a finite difference form in terms of Crank Nicolson scheme. Okay, so we are going to see example, okay, how we can apply, okay, how we can use all this formula to find the solution of the heat equation.